Okay, good morning. You're on to Mamu with Jarvis, and it's another learning experience time. I trust you've had a good night's rest, and if you're in this side of the world, you'll be enjoying the weather with us here. Okay, so this morning we're looking at arithmetic. If you watch carefully on the board, I have deliberately said grade box, which means that for the first time, I'm taking a concept where the knowledge we're going to be working on is open to any class at all. One of the things I've noticed in teaching math is that some of the ideas that tend to give you issues are those ones that are at their fundamental level. So once you get the fundamental idea, it becomes easy to solve the problem. So starting off, we're looking at arithmetic. Factors and multiples is our focus. I will just take a problem. I saw this problem online and I felt it was a very creative problem, trying to connect so many other topics. It's factors and multiples, but in it, if you look at this very well, it's also looking like sets. This is what we call a Venn diagram. Venn diagram. It's a Venn diagram. And that's why the question says, put the numbers in the correct place in the Venn diagram. So sometimes I hear students say, I'm good at this topic. It's not just enough to say you're good at this topic. You must be good at all of them, because the whole idea is for you to network your thoughts. So we're given factors here, or will I say numbers here, and we are told that in this box or in this set, we have multiples of 5. And in this box here, we have what? Multiples of, factors of what? 30. So how do we do this? If you watch my previous videos, I'm going to especially attach the link of all the videos I've done on factors and multiples at the end of this. While posting it, I'm going to attach all the links so that you can quickly go back to see what you need to remember in handling this topic. So with what we have on the board, we'll take a very simple approach. I'll just first of all say what? Multiples of 5. So what are the multiples of 5? It means read in 5s. 5 times 1, 5. 5 times 2, 10. 5 times 3, 15. So I'll simply write that. I'm going to have 5, 15, 5, 10. Sorry about that. 15, 20, 25. Remember, this is 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, 5 times 6. I'm also teasing another interesting concept here we call sequence. So we'll come to that much later, but I'm just trying to use this one topic to show you that with one topic, you can actually touch a number of topics. So 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, 5 times 6. Maybe I'll just do something like this. So 5 times 1, 5 times 2, 5 times 3, just like that. And then we'll have those answers. So I deliberately stopped at, okay, I can take it further. I can say 5 times, maybe I should clean this a little. So I can get up to, let's clean that. Let's have a number of them. 5, 10, 15, 20, 25, 30, 35, 40. I'll stop at 40 because the highest number I can see is what? 35. Now, these are the multiples of 5. Now we'll come to factors of what? 30. I'm still going to use this approach. You know, from my study, recent research, I've discovered that this approach of trying to write the multiples appear to be the best approach to handle, getting your factors. Opinions differ, but I think this is the best by my calculation. This will be 30 equal to what? 1 times 30, which will be equal to 2 times 15. This will be equal to 3 times. I just need to remember the factors that I can easily get from it. 3 times what? 10. And here I could have what? 5 times 6. I think that's about all you're going to have. So you discover that these are all the factors I'm going to have. So I will simply just list them here as what? 1, 2, 3, 5, 6, 10, 15, and what? 30. So with this done, I'm going to come to this part of my board. I'm going to give a summary of what I've done. I'm taking time to solve this because this is where it becomes very tricky. You can do them randomly, but I want to take out time to give you them in detail. So I'll look at multiples of 5, and I'm going to have 5, 10, 15, 20, 25, 30, 35, and I just decided to stop at 40. But the highest I have here is what? Okay, sorry about that. Oh, sorry about that. I just discovered I have up to 60. Oh, so sorry about that. I have up to what? 60. 60, please, let's confirm that. Let's be sure that, okay, I'm on course. I'm on course, fine. There's no problem. There's no problem. I'm on course. I'm on course. So we can stretch this further. Multiples of 5. I can stretch this further. I can take this to what? 45, 50, 55, 60. Now, please, when solving problems, if you make a mistake, don't really bother. It's normal. Some of these mistakes help to sharpen your sense of observation. Good. Now, I just noticed that I didn't see this 60 previously. Right. So with what we have, I also now take my factors of 30. Remember something very important. So the factors of 30 can never be greater, or rather, if I'm talking about the factors of a particular number, I can't get a number higher than that number as a factor. For instance, if I'm looking at the factors of 30, the highest factor I can get is what? 30. I can't get 60. No. 30 can be a factor of 60, but 60 cannot be a factor, because remember that the whole concept of factor is to have a whole number that can divide another without a remainder. All right, so that said, I'll come back to the board. I'm going to have 1, 2, 3, 5, 6, 10, 15, and 30. Now, the next thing I'm going to look at now is I look at the board. What are the numbers? Because I will not work with all of this. I only did this to show us an illustration. I'm not going to work with all of this. So what I'm going to do, I'm going to cancel out the numbers I don't have. I have 1. Do I have 5? Yes. Do I have 10? Yes. Do I have 15? Yes. Do I have 20? No. So I don't need it. I don't need 25. Do I have 30? Yes. Do I have 35? Yes. Do I have 40? No. Do I have 45? No. Do I have 50? No. 55? No. 60? Yes. So these are the numbers I need from the multiples. Now I have 1, I have 2, I have 3, I have 5. Do I have 6? No, I don't have 6. So I don't need 6 in this arrangement. Do I have 10? Yes. Do I have 15? Yes. Do I have 30? Yes. Do I have 30? No, I don't have 30, so I don't need 30. Because your solution must be based on what you have here. Others, I know students who can do this faster than this, but I'm just trying to take it gradually so you can see what you need to do. Fine. So with that said, I'm going to now fix them. The first one I would fix must be the numbers I see that are the same. Look at this and look at this. What are the numbers that are the same? You discover that 5, 10, 15. I can see here 5, 10, 15. You see this place where the circles appear to curve together. I mean, that's the place where numbers are the same. It's called intersection, but that's where we have numbers to be the same. So I'm going to have here what? 5, 10, and 15. So I've used 5, 10, and 15. So I'm going to circle it to tell myself that, sorry, I've not used 3, sorry about that. 5, 10, and 15. I'm going to circle them to show that I have used them. 5, 10, and 15. I've used them. Now, the next one I'm going to check now. Okay, I've cancelled 35. The next one I'm going to use now will be what? Factors of 30. I'm going to do what? Use what? Factors of 30. Okay, I'm to cancel 30 here too because I don't need 30. I didn't have 30. Give it to me. So what is left? I have 35 and 60 left. I have what? 35 and 60. So these are multiples of what? 5. So I have 35 and 60 here. Now, factors of 30. Factors of 30. Now, I've used 35 here, I've used 60. But look at what is left after this combination. I have 1, I have 2, and I have 3. So I'm going to have here what? 1, 2, and 3. These are standalone factors left after the intersection with multiples. These are standalone multiples of 5 left after the intersection with this. So this is what the correct answer ought to be. So that's what the answer to this problem would look like. So let's take a look at it, spend a little while looking at it and see how that plays out.